Okay, the next 19 PowerPoint slides reviews somewhat in more detail regarding the intrusion detection logic, which is based on the structure of a file layer internet model. So in here, we'll go a little bit more in depth regarding the anomaly-based intrusion detection versus the signature-based. And we'll make reference to the TCP control flags that we talked in the TCP voiceover PowerPoint slides. Basically make a reference to a sync flag, sync and ACK, RST flag, etc., etc. And that feature is being used by the intrusion detection hardware and software to identify the nature of the packet that is floating around in the network. And then IDS can detect such packet and then generate an alarm to the network administrator, some unusual activity going on in the network, etc., etc. So let's proceed with the next slide, and that talks about what is anomaly-based intrusion detection. So the anomaly-based intrusion detection triggers an alarm on the IDS, which stands for Intrusion Detection System, when some unusual behavior occurs in your network. Meaning you define a baseline, and if you see a deviation away from the baseline, that would imply some kind of abnormal behavior on the network. So for example, if the database software, database management, or if the database is normally accessed heavily between 3 to 5 every day in the evening, and the network administrator or a security engineer observe that the database is being accessed heavily after midnight when there is nobody else on the at the work, then that would be considered to be behavior away from a normal behavior. And so once you define the baseline behavior, then the amount of traffic that is deviation away from a normal would imply that there is some strange activity going on. Maybe a hacker has managed to enter the network and now wants to go through the database software. And so examples of anomalous behavior would be HTTP traffic on a non-standard port. Normally, HTTP traffic could run either on a port 80 or port 443, but never requesting a service on port 53. Port 53 is used for the domain name server resolution. Backdoor service on a well-known standard port, for example, peer-to-peer file sharing on port 80, that's not normal. A segment of binary code in a user password, or too much UDP compared to a TCP traffic, right? And so anomaly-based intrusion detection will continue. So as you said previously, an integral part of baseline network behavior is the engine's ability to dissect protocols at all layers. So if you know what the baseline network behavior is, then you can understand the protocols that come into play at the TCP layer, right, or at the transport layer. And so for every protocol that is being monitored, the intrusion detection engine must possess the ability to decode and process the protocol in order to understand the goal and the payload, right? And so, of course, there's pretty time-consuming activity to take every packet, open up the headers, and see what's going on in the right. So for a disadvantage of anomaly detection engine is the difficulty of defining what are the rules. So you must define the rules and then compare the packets against those rules, right? So you have a bigger, so for a really an enterprise network, you must have a set of rules, right? So the IDS would be a detection engine and a database of the rules. And if it finds that this packet is showing an abnormal behavior, then it needs to examine that packet against a set of rules, right? And the set of rules is then going to guide the engine to either identify that as a deviation away from the normal behavior, meaning this packet is a threat to the network. And in the PowerPoint slides provided by the author, it talks about different kind of statistical tests one could use for anomaly-based intrusion detection. And I give you a simple example. And I'm pretty sure all of you done ISDS 361A or 361B must have come across what we call a chi-square test, right? And so the way the chi-square test works is the following. First, you hypothesize that the packets, or rather the TCP segments with the reset flag set is 20%, sync and ACK is 60%, the ICMP packets are 15%, and the other is 5%, right? So you set up a hypothesis and say, I'm going to observe TCP segments 20%. So if there is a deviation away from it, that means there is something abnormal going on. And likewise. So you'll observe the frequency of RST, sync, and ACK. Then you'll compute the expected frequency difference squared and all of that stuff. You set up the hypothesis and we'll see, and then you compute the number and you do a comparison with the expected as opposed to what you normally see. And that tells you here. So you set up a null hypothesis that all category of packets occur with same probability, meaning equally likely, right? An alternate hypothesis, not all occur with the same likelihood. So either you can reject the null, implies there is an abnormal traffic on the network or not, right? And then one can actually go more in depth. So there are different kinds of, one can actually use machine learning and analytics to analyze the traffic and draws a conclusion. So the next we want to now move into what we call signature basic. So this is not a rule base, but there is a set of signatures or patterns given in a database. For example, like virus detection software, right? From different companies, right? So you're going to capture a packet and you're going to look for a signature in the packet, right? So basically we are saying, and kind of let's go into it. So you have a database in here, not a set of rules, but it'll say different signatures. This packet has got this signature. So you capture a packet and you look at the signature of the packet. And so this is, I'm talking about in an abstract way, right? If the signature matches, then it identifies a threat, could be a virus, could be a worm, right? So it looks for a pattern of strings of 1 and 0. And I can't get into detail because I'll be kind of going into computer science. So you look for a pattern of strings of 1 and 0. And if you find that the strings of 1 and 0, what we call identify as a pattern, looks similar to what's in your database, that would mean that that packet is a threat. So for example, connection attempt from a reserved IP addresses, right? A packet with an illegal TCP flag combination, right? So we could have a sync packet, meaning a segment with a sync flag setting, or a segment with a sync and ACK flag setting, or an ACK flag. But if you see any other combination, that would imply that the signature is telling you that this packet is a threat to the network, right? So email containing a particular virus. For example, a denial of service attack on a server caused by issuing the same command thousands of times, right? So this, by that we mean UDP flooding, ICMP flooding, or sync spoofing, right? So basically you're going, example here is a classic example of this is a TCP packet with sync and fin flag. So that's considered to be not the correct signature of the packet. So you could have a TCP segment with a sync flag set or a sync and ACK, but you cannot have a segment with a sync and fin flag both set to 1, right? And so that's in violation of the RFCC request for comment 793. And so you're looking at the signatures. You actually have to take the packet and examine the patterns of 1 and 0. And here we describe that in words, but the intrusion detection software will have to actually look at the strings of 1 and 0 and then make a determination of what's going on. And of course, an attacker is free to set whatever flags he chooses. So actually, on the internet, you can download programs, hacking programs, that will let you build your own IP header, a TCP header, and in the TCP header, you can set your own or assign values to the SYNC, the RST, the ACK, and the FIN bits, right? So when we go to the next chapter, chapter number 9, we'll talk about the firewall. And so these PowerPoint slides will help you to understand when we go into the firewall. So suppose you have what we call a liberally defined firewall, which passes packets if the FIN bit is set, right? Meaning FIN, meaning I'm done with you, I want to close my port, regardless of the value of SYN bit. And suppose you have a liberal host that accepts a SYNC bit as the opening of so you have a SYNC, you have a TCP segment with both SYNC and a FIN bit set, right? And your security policy on the firewall says, hey, if I see a TCP segment with a SYNC, then that must be requesting for a connection-oriented service, and I must let that packet come through, right? And so this way you can actually establish a connection behind the firewall. And a firewall is a device that separates the inside of the network from the outside of the network. So if you think of a door as a firewall to your house. So again, let me put this in word. In fact, the firewall says, I will let this packet pass because it's a FIN packet. But the host says, I'm going to establish a connection because it's also a SYNC packet. So having only the SYNC and FLIC sets is a well-known sign of a malicious activity, meaning you want to bypass the rules on the firewall. And what is a firewall? Firewall is a combination of hardware and a software, and it checks each packet that is coming into the intranet and each packet that is going out of the intranet. So intranet is nothing other than a network that is behind the firewall, and the network that is on the other side of the firewall, or what we call the after the firewall, is the internet, right? And so another highlight in red is another sign that these crafted packet meaning the packet actually built by a hacker, is that the acknowledgement number has various values, but the ACK flag is not set. So this kind of going back onto the TCP voice over PowerPoint slides that we talked about, the ACK flag and the acknowledgement number. Another suspicious characteristic is the source and the destination ports are both set to 21. We know that FTP runs at port 20 and 21, and port 20 is for exchange of data, uploading, downloading data, and port 21 is to keep the connection alive. This may be a little bit beyond the scope of this class, but I just kind of going to throw in the TCP window size, which is set to 1028. What does that really mean? When I'm talking to a web server, my web client says to the web server that I can only get up to 1028 TCP segments because the computer has a buffer and the buffer receives the segments from the server. And he said, if you send me too many segments, I'm just going to get overfilled and I will lose a connection. This is in case if you're more interested in it, right? And so remember that the echo request, echo reply, which uses the ICMP protocol, these are connectionless, right? And UDP packets are also connectionless. And why do we call them connectionless? Because the entire message could be put into one packet. So for example, if I were to enter a classroom and say, is there a John here, right? So the statement is there a John, which is a question really asking, is there somebody by the name of John, right? And that could all be put into one packet. So I really don't need to establish a connection with each of the student in my class, but simply to throw the question, is there a John in this classroom, right? So that's what we mean by connectionless. If that was a connection oriented, then I would go to each student and say, are you John? Are you John? Are you John? So if there were 1,000 students in my classroom, and if each of the request to identify John took 5 seconds, it'll be 1,000 times 5. That would be a waste of time, right? So in that case, I would simply enter the classroom and say, is there a John in here, right? So that really doesn't take much bandwidth, right? So there are times on a network where we need both a connection-oriented service and a connectionless service, right? So for example, another example of a connectionless service would be when my client computer wakes up and says, I need an IP address, right? Like you guys do at home, right? You power up your laptop and your laptop gets an IP address from your access point, right? So your laptop simply says, hey, give me an IP address. And your access point assigns an IP address. Now, if that service was defined as a connection oriented, then your laptop will have to send a sync packet to your to the TCP protocol on the access point. It would then respond with a sync plus ACK, and your laptop would then respond with an ACK. That would be kind of a waste of time, right? So in here, we basically focus values in IP, TCP, UDP, and ICMP, and also DNS. The reason has to do with the way the packets are structured, and what I mean by that is we looked at the TCP header and the IP header, right? So in the final slide, we're going to look at the TCP control flags. And how do we do that? So you basically run a Wireshark program. This is a open source tool. It's basically a sniffer program that will capture packets running on the network. Now you can capture the packets two-way. If I were to run Wireshark on a host computer, for example, on a database, that'll capture the packets that are coming to the database, right? If I were to run the Wireshark program on a device called a switch, so switch is nothing other than a concentrator where all the device connects to it. Therefore, if you want to talk to any one of the device that connects to this concentrator called a switch, then, and if you install the IDS on a switch, then every packet that is going anywhere on the network will be captured by the IDS on the switch, and then you can examine the headers on the captured packets. So basically, you examine the TCP header to identify the nature of the TCP segment, and then you can refer to that to a TCP over PowerPoint slide. So let me describe. So if you see in the TCP header, the value in the control flag 0x01, and these are hexadecimal representation. And so basically you see something called 0x01. So if you were to capture TCP segments using Wireshark and you examine the TCP header and you see the value in the flag 0x01, that means this is a fiend flag set in the TCP segment. If you see 0x02, again the 0x says this is a 02 is a hexadecimal number. And hexadecimal numbers are run numbers that are valued from 0 to 15. So there are 16 digits that run from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E. I have a captured packet called Apache.1, and I'm going to ask you to actually open that up in Wireshark, or I may do a demo for the next Zoom session. So, but all this is says if you see a 03, meaning both FIN and a SIG flags are set, which is illegal, right? If you see a value 10, that means this is an ACK flag. And then likewise for the other one, right? So hopefully these 19 set of PowerPoint slides gives you a little bit more deeper look into the chapter 8 PowerPoint slides provided by the author. And then you also need to review the TCP over PowerPoint slides. And I think that's the end.